Hello, my name is Miguel Mendoza and welcome to Micrel TV. Today we're going to show you a demonstration of the MIC28304, our first micro module that operates up to 70 volts. Before we get started, I'm going to kind of show you a little bit overview of the setup, and then I can give you some of the insights of the micro module. So let's get started. So here we have an offline. So this is using the MIC28304 PWM controller. Now this is a flyback topology. So that way you have the balance between efficiency as well as cost. And we're also using a primary feedback loop to actually control the secondary. And that way it minimizes the cost by not having to use an optocoupler. But this is still an isolated supply, and this is taking 110 volts AC and is providing a 24 volt DC, and it regulates very well. So this 24 volt goes into the micro module. Now the micro module is actually bucking it down to 12 volts DC, and then that's providing the power to drive this LED driver demo that we have using a 4 amp LED from Osram, which actually has 4 dies that each requires 1 amp at peak current, and it has a red. Let me show you the white LED. It's got a blue LED, it's got red LED, and it's got the green LED. And this is typically used for architecture lighting as well as for stage lighting. So this at full tilt, now I'm going to only keep this briefly, it's about 1000 lumens. But let's just reduce the light so we can see what we're looking at here. So the LED driver module uses 4 MIC3203 LED drivers. Now these are buck LED drivers. And we're also using 2 comparators for each channel. Actually 1 comparator to provide the PWM frequency and 1 comparator to provide a nonlinear dimming profile. That way I have more smoothness control over the pot. Instead of having the linear profile that typically looks like a step function when you look at it, we have a much smoother dimming profile by using log scale. Now that gives you the nonlinear dimming ratio, which gives you more resolution on the low light. And the reason why is because our eyes are more acute to low light than we are to high brightness. So that just gives you a lot easier for the user to control and also mix around the colors, as well as to try to provide a white light with good CRI or color rendering index. So let's talk a little bit about the micro module. Now the micro module has a wide input range. It could be as low as 4.5 volts, as high as to 70 volts, continuous. Now most applications typically would provide a 12 volt or a 24 rail, as well as a 36 volt rail, maybe as high as 48 volt rail. And then typically you would buck it down to either 5 volts or 3.3 volts to bias your electronics. Now in this case I'm using 12 volts, so I can give myself a little bit more range. So if I wanted to put extra LEDs in series, then I can do that. And also to be able to provide maybe close to 2 amps, so I can actually show you how well the thermal behavior is for this LED driver as part of this demo. But so let's just review some of the highlights of this micro module. The wide input range. Now not only does it allow you to be flexible on your input range, but also if there's any transients on the line, because you have up to 70 volts of input range, it becomes not a problem. So effectively it has transient protection. And it's very efficient as far as taking, like for example, 12 volts to 5 volts. It's got over 93% of power efficiency, and it's got very good thermal response. So let me kind of show you this. Even though this is not a steady state, so we're not letting the temperature, but let's see if we can just kind of see and give you a better view. Can we get the lights, please? So even though it still hasn't warmed up to full, you can see that it's only at about 52 Celsius. Let me see if I can center it properly here. Now I do have a slide that I can show you after it's been running for about 20 minutes. That way we can give it a true test where we're closer to about 59 Celsius. But as you can see, it's warming up, but eventually it'll hit the steady state. So it's okay. So going back to the demo, can I get the lights, please? Thank you. So another thing is this microcontroller uses a constant on time, and that has we have adapted the on time that has really good transient response. So when you change the current needs of the load, it has very good on time, which I just now destroyed my, there's an off switch. So you can see that the driver has no problem adjusting to the load changes, and that's because it has very good transient response. Another thing that the device has, it also has current limit. So effectively you can program the current limit to not to exceed to a certain value. That way it protects your microcontroller as well as your circuitry. Thank you for your time and have a good day.